Good day, learners! Welcome to LBV GMath 1-2.6C. This is now the third video of the 4 videos where we discuss how to get the intercepts, zeros, and asymptotes of rational functions. I am Engineer Peter Benjamin Obiano, your lecturer for this video. We are still on the second chapter of our discussion on functions and their graphs, namely, all concepts regarding rational functions. For our topic outline, first we will learn how to get the vertical asymptote of a rational function and then how to get the horizontal asymptote of a rational function. So in this video, our focus will be on asymptotes. Now take note, yung dalawang naunang video, yung una, nag-discuss tayo doon ng intercepts and then doon sa pangalawa, nag-discuss tayo ng zeros. So take note po, again, this is now part 3 ng 1-2.6. At the end of the video, I hope that we will be able to learn how to get the vertical asymptote of a rational function and at the same time, how to get the horizontal asymptote of a rational function. Kung naalala nyo po, dun sa LBV 1-2.5, hindi ba nag-discuss tayo regarding the range and the domain of our function? And I believe, ang naging focus lang natin sa finding the range is on simple rational functions. At nasabi ko that time na if we want to get the range of more complex rational functions, then we need to discuss first yung concept ng asymptotes. Ito na yung gagawin natin sa video na ito. So in this video, I hope na matutunan natin paano mag-solve ng asymptote upang sa ganon ay makakayanan nating kumuha ng range and domain na din ng mga more complex na rational functions. Sige, let's have a quick review. Noong LBV 1-2.4, ang naging focus naman natin doon or isa sa naging focus natin doon is on graphing the function. And I believe isa ito sa mga graph natin. So f of x is equal to x minus 1 all over x minus 2. So hindi ba kung naalala nyo, so let's say nasa x-axis yung x, nasa y-axis yung f of x, and kapag graph natin siya, ito yung mangyayari. I believe noong graph natin to, na-introduce ko na yung tinatawag na asymptotes. Now take note, sa graph na ito, may tinatawag tayo na vertical asymptote at may tinatawag tayo na horizontal asymptote. Ano ulit ang mga asymptotes? Asymptotes are lines na kung saan yung graph natin, it will come closer and closer and closer to it, but it will never intersect with it. Kapag let's say, papalakihan natin yung graph natin at i-observe mo, makikita natin na yung behavior ng graph natin is palapit ito ng palapit sa mga asymptotes, kaya lang never silang magdidikit. Okay? So, halimbawa, as you can see, let's say you have your vertical asymptote. Habang palapit ng palapit yung graph natin sa vertical asymptote, palapit ito ng palapit sa kanya. Pero, there will not come a time na mag-i-intersect sila. So, ganun din dito. Okay? So, it will come closer and closer, but it will not intersect with it. So, yun yung concept ng asymptotes. Alright, so let's now take a look at the formal definition of our asymptotes. Unahin natin yung vertical asymptote. So let's say you have your graph, you have your vertical asymptote na tatawagin kong x equals k. Now take note, vertical asymptote is syempre vertical. Kaya nga, pag bibigyan mo ng equation, ito, that is x equals a certain number. Depende kung nasaan siya sa may x-axis. Anyway, so let's say, si x equals k ay isang vertical asymptote ni f of x. Okay. Ano ngayon ang ibig sabihin nun? Now, take note, the vertical asymptote of a function is a vertical line x equals k. Again, ito yon showing where the function becomes unbounded. Ano ulit ang ibig sabihin ng unbounded? Unbounded means eventually it will approach positive infinity or negative infinity. This means that, so in-expound ko lang yung definition, this means that as x approaches from the left or from the right of k, the values of f of x or y, depende ano kung yung function mo ba in terms of f of x or in terms of y. Anyways, so again, this means that as x approaches from the left or from the right of k, the values of f of x or y approaches either positive infinity or negative infinity. So again, let's say, ito yung vertical line natin. Kapag daw yung curve mo, it approaches either from left or from right. So halimbawa, let's say, tignan natin tong part na ito. Makikita natin that your graph is approaching from the right. So yung graph mo, galing sa right at palapit ito ng palapit sa vertical asymptote natin. Ano ang nangyayari? Sabi dito, kung vertical asymptote nga siya, kapag palapit ng palapit yung graph mo sa ating vertical asymptote, yung value mo ay palapit ng palapit sa positive infinity. So, ibig sabihin nito, kapag i-graph mo to, galing sa right, papuntang left, pataas lang ng pataas ito. So, tatas lang yan ng tataas, tataas ng tataas. Again, asymptote siya. So, never siyang didikit sa asymptote. Palapit lang ito ng palapit sa asymptote. At the same time, yung value mo, pataas din ng pataas hanggat it approaches positive infinity. Ganon din dito sa may bandang baba. So, you have your vertical asymptote, meron kang graph na ito naman galing sa left papuntang right, pero the same behavior, habang palapit ng palapit ito sa ating asymptote, makikita natin pababa ng pababa ang kanyang value. Again, kung let's say tinuloy-tuloy mo tong graph na ito, makikita mo na habang palapit ng palapit yung graph sa vertical asymptote na ito, yung value ng function mo ay palapit din ng palapit sa negative infinity. So, ganon siya. So, that is a vertical asymptote. Now, ano naman itong k na ito? Ito yung gagamitin natin mamaya para ma-solve at mahanap yung vertical asymptote. So, sabi dito, the values of k, this one, are the values of x that will make the denominator of the rational function equal to 0. So, kung ano daw yung mga values ng x na magpapa-undefined sa ating rational function, yun yung k natin. Again, kailan ulit mag-undefine ang rational function mo? That is if your denominator is equal to 0. So again, the third definition, this will be our guide later in finding the vertical asymptotes. So ganoon lang. So again, ano ang vertical asymptote? Isa siyang line na kung saan habang yung graph mo ay palapit ng palapit sa kanya, ang value ng graph mo ay palapit ng palapit either sa positive infinity or negative infinity. Okay, so let's go naman sa next. You have the horizontal asymptote. Tawagin ko naman ito na y equals k. Again, this is a horizontal line. So, y equals k. Y equals something. Ano yung something na yon? Well, depende kung nasaan siya along the y-axis naman. Alright, formal definition. The horizontal asymptote of a function f of x is a horizontal line y equals k that the graph of the function approaches as x approaches infinity or negative infinity. In other definition, this means that as x approaches positive infinity or x approaches negative infinity, the value of f of x approaches k. Sige, para medyo mas malinaw ng konti, sige, maglagay tayo ng kunyaring value para kay k. Kunyari lang. Kunyari, ang value ni k ay 3. So, kunyari, palitan ko si k ng 3. So, interpretation ngayon nito, as x approaches infinity or x approaches negative infinity, the value of f of x approaches 3. Ibig sabihin nito, let's say, tinuloy-tuloy mo tong graph, habang yung value ng x mo ay approaching positive infinity. Ibig sabihin, kapag tinuloy-tuloy mo tong graph na ito, palapit siya ng palapit sa 3. Yung value ng graph mo ay palapit ng palapit sa 3. Ganon din dito. Habang let's say yung graph mo ay papunta naman sa negative infinity, as x approaches negative infinity, pag tinuloy-tuloy mo yung graph mo to the left, malalaman mo na yung value ng function mo palapit din ng palapit sa 3. So, yun ang horizontal asymptote natin. So, I hope clear yung naging difference ng dalawa. In general, ang asymptotes ay mga lines na kung saan yung graph mo palapit ng palapit ng palapit sa kanya, kaso they will not intersect with it. Okay? So, ayun siya. So, yun yung general na definition natin. Pero later, actually, in the next videos, malalaman natin, minsan, pwedeng tumawid ang graph mo sa horizontal asymptote. So, ibig sabihin nito, yes, in general, asymptotes are defined as lines na kung saan palapit lang ng palapit yung curve pero hindi niya ito i-intersect. That is strictly for vertical asymptote. So, totoo yun lagi sa vertical asymptote. Pero, I think sa next video yun, makikita natin, pwedeng tumawid yung graph sa horizontal asymptote. Pero regardless, ma-experience mo pa rin yung behavior na ito. Okay? So, di bale, I believe if, let's say, in-apply na natin ang asymptotes sa graphing, mas maintindihan natin ano ang ibig kong sabihin doon. Okay? For now, for this video, ang focus lang muna natin paano kunin yung asymptotes. Yung additional application, interpretation of asymptotes, sa next video na natin yon gagawin. Okay? So now let's go to our process. How to get the asymptotes. Unahin natin yung vertical asymptotes. So step 1, in the given rational function, factor out both the numerator and denominator. Cancel out common factors if there are any. As you can see, yung umpisa, parang yung umpisa din ng finding the intercepts and roots, if you remember, di ba? Factor out kung pwede, cancel out yung factors na meron, kung meron. Okay? After step 1, using the reduced rational function na tinawag kong gx, so para hindi tayo ma-confuse, so f of x, tatawagin ko para sa original function. G of x naman, ang tawag natin doon sa reduced rational function, yun yung result ng step 1, kung nag-cancel out man tayo. Okay? So, moving on, using the reduced rational function na tatawagin kong g of x, find the values of x that will make the denominator of g of x equal to 0. Ngayon, kung marami man sila, ay di tawagin natin sila na k1, k2, k3, kn, and so on, so on. Depende kung ilan yan. Step 3, the vertical asymptotes of the original function f of x will be, so the first vertical, x of 1 is equal to k1. Again, kung madami sila, so x of 2 is equal to k2, x of 3 equals k3, and so on and so on. So basically, tatlong steps lang naman ang vertical asymptote. Step 1, factor out the numerator and denominator. I-cancel out yung mga maka-cancel out kung meron. Step 2, doon sa nakuha mong function sa step 1, hanapin mo yung mga values ng x na magpapa-0 sa denominator. And actually, yung mga values na yun na yung ilalagay natin sa x equals k. To get naman the horizontal asymptotes, first, dapat alam natin yung degree ng polynomial. Ano ulit yung degree ng isang polynomial, di ba? The degree of a polynomial is, sabihin na natin, the highest exponent that you can see sa polynomial mo. So again, di ba, para makuha mo yung degree ng isang polynomial, hahanapin mo yung pinakamataas na exponent ng x. So I hope you remember that kasi gagamitin natin yun ngayon. Alright, how to get the horizontal asymptotes? Given the rational function f of x over g of x, so again, rational function meaning sina f of x at g of x ay parehas na mga polynomials. Okay. Now, the horizontal asymptote depends on the degree of the numerator and the denominator. It depends kung alin ang may mas mataas na degree, yung nasa numerator ba o yung nasa denominator. Now, ito yung mga conditions natin. If the degree of the numerator is greater than the degree of the denominator, then the rational function has no horizontal asymptote. Kapag daw mas mataas yung degree ng polynomial na nasa numerator kesa sa nasa denominator, wala tayong horizontal asymptote. Okay? Next. If the degree of the numerator is lesser than the degree of the denominator, then the horizontal asymptote is equal to y equals 0. Kapag daw yung degree ng numerator mo ay mas mababa kaysa sa degree ng denominator, automatic ang horizontal asymptote natin ay y equals 0. Lastly, if the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is equal to y equals k, where k is the quotient of the numerator's leading coefficient and the denominator's leading coefficient. I hope naalala nyo pa itong mga terms na ito. Ano ulit ang leading coefficient? Leading coefficient, yung coefficient ng leading term. Ano ulit ang leading term? Hindi ba yun yung term na kung saan yung x ay naka-raised doon sa degree? So in short, hanapin mo lang yung coefficient nung x na may pinakamataas na exponent, di ba? Yun yung tinatawag natin na leading coefficient. Again, kung nakita mo na equal yung degree ng numerator at denominator, para makuha mo yung y equals k, pag-dividin mo lang daw yung leading coefficient ng numerator at yung leading coefficient ng denominator. Okay? So, yan lang yan. So, yan po yung mga steps natin on getting the asymptotes. Now, i-share ko lang yung isang guide na nakita ko sa internet para siyang shortcut para at least madaling matandaan yung horizontal asymptote. Okay? So, the mnemonic is like this. So again, given the rational function f of x, g of x, just remember the mnemonic BOTN. Or, I don't know, ikaw, bala kang paano mo babasahin to. Boton. Yan, boton. Or BOTN. It's up to you. Anyways, ano ibig sabihin ng BOTN? BOTN stands for if the degree is bigger on top, no horizontal asymptote. So, yun ang ibig sabihin nun. Bigger on top, no horizontal asymptote. Okay? Yun yung BOTN or boton. It's up to you kung paano mo ito i-pronounce. Next, you have BOBO or, well, forgive me for the term, it's bobo. Yan. So, second mnemonic is bobo. Ano naman ang ibig sabihin ng bobo? BOBO stands for if the degree is bigger on bottom, O, the second O represents 0. Okay? So, if the degree is bigger on the bottom, the asymptote is y equals 0. So, yun ang ibig sabihin ng BOBO. Lastly, you have it's DC. Yan. So, kumakain DC. Yan. It's DC. Ibig sabihin naman ito, exponents are the same, divide coefficients. So, di ba? Kapag pares yung degree, i-divide mo yung leading coefficient ng numerator at yung leading coefficient ng denominator. So, yun ang ibig sabihin nito. Okay? At kung ano man yung nakuha mong sagot, yun yung k mo doon sa y equals k. So, yun lang. So, again, if you want an easier way to remember the horizontal asymptotes, how to get the horizontal asymptotes, you can refer to this one. Kasi most likely, ang mapagbabaliktad natin yung unang dalawa. Ito kasi equal. Madali lang naman. Pag equal, pag divided mo yung dalawang leading coefficients. Siguro ang mapagbabaliktad mo yung mas mataas yung degree ng isa. Kaya nga maganda rin na may simpleng mnemonic tayo. Okay, so yun po yung steps natin. Sige, apply lang natin sila. Let's answer the following exercises. Exercise 1, find the vertical and horizontal asymptotes of -4 all over x minus 2. So in these exercises, ang una nating isosolve muna ay vertical asymptote and then horizontal asymptote. So sabay na nating isolve yung vertical at horizontal. Sige, unahin natin yung vertical asymptote. Let's follow the steps. Again, ano ulit ang step 1 ng vertical asymptote? You factor out the numerator and denominator. Kung mayroon bang magka-cancel out, i-cancel out mo. Kaya lang, base sa given natin, as you can see, simplified na ito. Simplified na siya. So, wala nang mas sisimple pa dito. So, the rational function can be simplified further. So, in short, tapos na tayo sa step 1. Let's now go to step 2. Using the reduced rational function that we found out. Again, hindi naman talaga na-reduce kasi in the first place, wala naman nang i-reduce ito. So, at the same time, ito na rin yung ating reduced function. Okay? So sabi dito, using your reduced rational function, find the values of x that will make the denominator equal to 0. Yung denominator mo ay x minus 2. Ano yung x na magpapa-0 sa x minus 2? Siyempre, in order to get that, i-equate lang natin yung x minus 2 sa 0. And then, of course, masosolve natin x equals 2. Okay? So, yun siya. Therefore, the vertical asymptote is x equals 2. So, yun lang. So, we now have our answer. So, our vertical asymptote is x equals 2. Puntahan naman natin yung horizontal asymptote. Again, bago tayo makapag-solve, i-identify mo muna ano ang degree ng numerator, ano ang degree ng denominator. Okay, numerator muna tayo. Ano ang degree ng numerator? Well, makikita natin si numerator is simply a constant. Walang x. So, walang x. Meaning, ang degree nito ay 0. So, the degree of the numerator is 0. Yung baba naman, x minus 2, the highest exponent of x that we can see here is 1. So, dito. So, ang highest exponent na nakikita natin ay 1. Therefore, the degree of the denominator is 1. As you can see, the degree of the numerator is lesser than the degree of the denominator. Yung degree ng numerator ay mas mababa kaysa sa degree ng denominator. Alin ngayon sa tatlo ang gagamitin natin? Yung BOBO or BOBO. Yan, yung BOBO. Since the degree or since the exponent is bigger on bottom, the horizontal asymptote is 0. So therefore, the horizontal asymptote of this one is y equals 0. So ganun lang yan. Just apply the steps. Remember the steps and apply them. Ang problema na lang po natin dito is memorization ng conditions ng horizontal asymptote. And siguro pag-sablay ka pa rin sa factoring, baka madali ka sa vertical asymptotes. Let's have another exercise. Find the vertical and horizontal asymptotes of f of x equals 6 minus 2x all over 1 minus x. Again, unahin natin ang vertical asymptote. Paano ulit kunin ang vertical asymptotes? Try natin i-factor out ito. And let's see kung may maka-cancel out ba. Kaya lang, mukhang wala naman ng mas isisimple pa ito. Kahit pa nasabihin mo, i-factor out mo yung 2. Okay, so pag finactor out natin yung 2, magkakaroon ka ng 2 times 3 minus x, which is wala namang maka-cancel out. So, ibig sabihin nito, as is na to. So, this rational function can't be simplified further. Therefore, ito rin yung gagamitin na natin pangkuha ng vertical asymptote. So, let's go to step 2. So, again, yung function kanina na wala namang pinagbago, hanapin mo yung mga x na magpapa-0 sa denominator. Again, in order to do that, i-equate lang natin yung 1 minus x sa 0. And of course, pag ginawa natin yon, masosolve natin na yung x is positive 1. Therefore, the vertical asymptote of this function is x equals 1. Okay? I hope naging clear po iyon sa atin. Sige. Horizontal asymptote naman tayo. Again, para maumpisahan ang horizontal asymptote, i-check muna natin. Ano ba ang degree ng numerator at ng denominator? Numerator tayo, ano yung pinakamataas na exponent na nakikita mo sa x? Ito, which is 1. So therefore, the numerator has a degree of 1. What about the denominator? It's the same. Ang degree din nito, the highest exponent for x, is also 1. As you can see, equal yung dalawang degree. Since equal yung degree ng numerator and denominator, gagamitin natin yung its DC. So again, the exponents are the same, divide the coefficients. So kukunin natin yung quotient ng leading coefficient ng numerator at ng leading coefficient ng denominator. Sige, ano ba ang leading coefficient ng numerator natin? Nasaan ba yung leading term? Again, leading term is yung may term na yung x niya ay may exponent na equal sa degree. Yun yung term na kung saan yung x highest yung exponent. Well, isa lang naman ang may x dito, si negative 2x. Yun yung leading term natin. Ano ang coefficient ng negative 2x? Di ba? Negative 2. So, the leading coefficient of the numerator is negative 2. Use the same for the denominator. Negative x is our leading term. Therefore, the leading coefficient of the denominator is negative 1. And to solve for k, pag-divide din lang natin. Again, of course, numerator yung nasa taas. So, negative 2 divided by negative 1, you'll get positive 2. Therefore, the horizontal asymptote is located at y equals 2. So, ganun lang. So, just apply the process. So, that is for exercise number 2. Exercise number 3, find the vertical and horizontal asymptotes of f of x equals to x raised to 4 minus 5x cubed divided by x squared minus 6x plus 5. Unahin natin ang vertical asymptote. Again, i-factor out muna natin yung numerator and denominator and then cancel out the factors kung meron man. Okay, so unahin natin yung numerator. I-factor out natin yung numerator. Pwede nating ilabas ang x cube. So pag finactor out natin ang x cube sa may numerator, we will get x cube multiplied by x minus 5. I-factor out din natin yung denominator. So ano ang factor ng x squared minus 6x plus 5? So again, yung factoring natin, wag din syempre kakalimutan. Okay, ano ulit ang factors ng x squared minus 6x plus 5? We will get x minus 1 and x minus 5. So yung x squared minus 6x plus 5 is equal to x minus 1 times x minus 5. May pwede bang mag-cancel out? Meron. Yung x minus 5. So let's cancel them out. Therefore, ang simplified function natin is simply x cubed over x minus 1. Ito na ngayon ang gagamitin natin later panghanap ng vertical asymptote. Alright, from our previous step, nakuha natin ang simplified function nito, which is x cubed over x minus 1. Again, ano yung mga x na magpapa-0 dito? O, di ano ba yung magpapa-0 sa x minus 1? So, di ba, x minus 1, that is equal to 0. Solving for x, we will get positive 1. Therefore, the vertical asymptote is located at x equals 1. So, ganun lang. That is how you get our vertical asymptote. For the horizontal asymptote, again, ano yung degree ng numerator at ng denominator? Alright, ano ang degree ng numerator? So, makikita natin na ang degree ng numerator ay 4 kasi ang highest exponent ng x ay 4. So, the numerator is a 4th degree polynomial. What about the denominator? It's a 2nd degree polynomial. Mas mataas yung degree ng numerator kesa sa denominator. Ano ngayon ang gagamitin natin? Yung BOTN. Bigger on top, no horizontal asymptote. So therefore, ano ngayon ang horizontal asymptote nito? Wala. So wala siyang horizontal asymptote. So ganun lang. So that is how you apply BOTN. Sige, practice pa more. Exercise 4. Find the vertical and horizontal asymptotes of x squared minus 36 divided by x squared plus 9. Sige, vertical asymptote muna tayo. Factor out and cancel if may pwedeng i-cancel. Well, as you can see here, wala nang mas isisimple pa ito. Kasi di ba, yung denominator mo naman, hindi naman factorable ang x squared plus 9. So, walang magka-cancel out dito. So, therefore, ito na rin yung gagamitin natin for step 2. So, solving for step 2, so again, no, walang nagbago sa function natin. Ano yung mga x na magpapa-0 sa denominator? Ano yung mga x na magpapa-0 sa x squared plus 9? So, i-equate lang natin yung x squared plus 9 sa 0. Transpose yung 9 sa kabila, edi magkakaroon tayo ng x squared equals negative 9. And taking the square root of both sides, you have this. Eh, ano bang square root ng negative 9? Di ba wala? This is undefined. So wala kang makukuhang sagot for x. Since wala kang makukuhang sagot for x, ano nga sasabihin natin? E di wala. Wala tayong vertical asymptote. So ganun lang. So kung nag-undefined yung x, edi ibig sabihin nun, wala tayong vertical asymptote. So yun lang. So posible yan. Let's get the horizontal asymptote. Ano ang degree ng numerator? The numerator is a second degree polynomial. The denominator is also a second degree polynomial. Parehas ang degree ng numerator at ng denominator. Ano ang gagamitin natin? Yung its DC. Exponents are the same. Divide coefficients. Okay, apply natin yung its DC. Ano ba ang leading coefficient ng numerator? Ang leading term mo ay x squared. Ito yung leading term. Ano ang coefficient ng x squared? It's positive 1. Therefore, the leading coefficient is positive 1 for the numerator. E paano sa denominator? The leading term is also x squared, so same sila. The leading coefficient of the denominator is also 1. Again, let us divide the leading coefficients. So you'll get 1 divided by 1, which is equal to positive 1. Therefore, the horizontal asymptote is located at y equals 1. Okay, clear po. So, hindi naman po ganun kahirap ang pagsosolve ng asymptotes. Just remember the rules. Sige. Exercise 5 tayo. Find the vertical and horizontal asymptotes of x squared minus 9x minus 22 divided by x squared plus 2x minus 3. Let's start with the vertical asymptote. Factor out and cancel if meron man. Let's factor out x squared minus 9x minus 22. That's x minus 11 times x plus 2. Ano naman ang factor ng x squared plus 2x minus 3? Malalaman natin, it's x minus 1 times x plus 3. Again, no? Practice po tayo sa ating factoring. Kasi, hindi naman ganun kahirap yung process. Pero, siguro, madali ka sa factoring. Alright, may maka-cancel out ba? As you can see, wala. So actually, the rational function can't be simplified further. Alright, so again, wala namang pagbabago. Pero, kailangan pa rin natin actually i-factor out. Bakit? Kasi 'di ba aalamin natin ano yung mga values ng x na magpapa-0 sa denominator natin. So talagang kailangan pa rin nating i-factor out yung denominator. Anyways, 'di ba? Magzi-0 yung denominator mo pag isa sa dalawang to magzi-0. So yung usual na ginagawa natin, kunin natin yung isa, yung x minus 1 kunyari, equate mo sa 0, solving for x, you'll get positive 1. Kunin mo yung isa, yung x plus 3, equate mo sa 0, solving for x, it's negative 3. In short, dalawa ang vertical asymptotes natin. Yung isa, nasa x equals positive 1. Yung pangalawa, nasa x equals negative 3. For the horizontal asymptote, okay, ano ang degree ng numerator? The numerator is a second degree polynomial. The denominator is also a second degree polynomial. parehas yung degree nila. Ano ngayon ang gagamitin natin? Yung its DC ulit. Exponents are the same, divide coefficients. Based on the given, ang leading term ng numerator ay x squared. Therefore, the leading coefficient is positive 1. Para naman sa denominator, the leading term is x squared din. Therefore, the leading coefficient is also positive 1. Solving for the value of k, pag divided mo lang tong dalawang to, 1 divided by 1, you'll get positive 1. Therefore, the horizontal asymptote is located at y equals 1. Okay, so I hope no naliwanagan tayo kung paano kumuha ng asymptotes. Sige, that's the end of this video. I hope na mula sa 5 exercises natin, we were able to learn how to get the vertical asymptote and horizontal asymptote of rational functions. Getting the asymptotes are actually important because it will help you to graph properly your rational function. And at the same time, you need them if you want to get the range and domain of rational functions. So we're done with LBV 1-2.6C. Our next topic is the last video na sa 1-2.6. So the next video will be 1-2.6D. Ano naman ang i-discuss natin sa 1-2.6D? Let's apply the concepts of intercepts and asymptotes to get the range of more complex rational functions. So balikan na natin yung utang ko sa inyo noong LBV 1-2.5B. Kasi sabi ko dati, hindi tayo makapag-solve ng mas complicated na range and domain problems unless alam natin yung asymptotes. Ngayong alam na natin yung asymptotes, o di sige, let's apply them. Yun yung focus ng next video natin. Okay po? Again, if you want additional learning, kindly refer na lang sa QuexBook on General Mathematics Chapter 2. Stay safe, God bless po, and see you sa next video.